Hello, data scientists. We are Troy Sadkowsky and Dave Kielpinski, and we are here on a beautiful winter's day, a sunny day in Brisbane, Australia. And we do, live in the same place, but we're coming from our homes. Sorry, we live in Brisbane, but coming from our individual homes here around Brisbane City. And this is our first episode that we are putting together for a little data science series that we're going to be calling So You Think You're a Data Scientist. And in that series, we're going to be looking and reaching out to data scientists from all around the world and asking them their opinion about what they do as a data scientist, how they got into data science, and everything about data technology, scientific application of this data and knowledge. So since it is our first episode, we're going to do a little intro of ourselves, and then we're going to be answering some hard-hitting questions around data science. Well, the number one being jokingly, is it data or is it data? But after we get past that one, we'll go to what is data science, and more importantly, what does a data scientist do? And then we're going to be just opening up a little bit of conversation between Dave and I about what we're up to, and then end it there. So first, over to you, Dave. Let us know a little bit about you, about yourself.
Yeah, thanks, Troy. So I've been in the data or data space, depending on which pronunciation you prefer, for about 7 years now, explicitly in data science type roles. And during that time, I've worked across a number of different industries, including semiconductor fabrication, drug discovery, cybersecurity, and my work has spanned kind of the entire data lifecycle between ingestion, a bit of data engineering, modeling, including neural networks and machine learning, and then bringing those back home to customer insights, because at the end of the day, for all of us in the data space, generating that business value is what's really important. For the last year, I've been running my own machine learning consultancy. I started that while I was in Silicon Valley, where I've done most of my work in this space. So I've been, so I was there for the past 7 years in the US in the San Francisco Bay Area region. Before that, I lived in Brisbane for 10 years, and I was a professor of quantum computing at Griffith University, running an experimental research lab there. So, so the transition to machine learning was an interesting one for me. I always was wanting to do sort of applied and translational research as a professor, trying to build a quantum computer. And so it was really nice to get to transition into that more immediately applied focus when I moved back to the States for a while. Right. And so, so I've really worked across all the layers of the computing stack, from the most basic like logic gates all the way through to sophisticated deep learning production code. And as I said, right now I'm a machine learning consultant, and I think Troy and I might be talking a little bit about how the sector works in Brisbane, which is something I'm quite keen to learn more about, having just recently moved back. So exactly. Thanks, Troy.
Yeah, well, it's really, so much in there as well. To kind of set people up for what's to come, I think in the next episodes, we'll be, I really want to learn more about your quantum computing background, and where you see quantum computing headed as well in the future. But I think this one, we're going to be kind of condensing it down, keeping on track to, these data science aspects. And from my side, So I'm Troy Sadkowsky, and pioneer data scientist. So as people have been giving me that title, as they gave me the title of data scientist, it was back in 2008 when I was kind of stumbling around the world, not knowing where I fit or what to do with my life. I found myself with a degree in science, a degree in IT, and a partial MBA. I had my own company doing this consulting services, helping mainly researchers and academics. I was the interface to the data and technology, and they had such important jobs that they found the need to get somebody else to help them. And we covered things like data management, the analytics side, and the visualization, which we'll talk a little bit more about later. But yeah, as I heard these words, I was at a conference one day just promoting my business. And someone came up to me and he asked, what do you do? And I explained to him basically what I've just been talking about now. And he said, you know what you are? We have a name for guys like you. We call you data scientists. And yeah, that was back in 2008. And when I heard those words, it felt like the heavens had opened up and God himself had labeled me with a purpose and a direction. And I ran with it so much that that night, this is in Melbourne, I went to my hotel room. I used their Wi-Fi to check out who had datascientist.com, and nobody had it. So that's when I bought the domain and yeah, set out my path to be the best data scientist I could be. And I had an experience in health and cancer research and epidemiology, and I continued to do that, develop some software and build a name for myself with datascientist.com and my associated YouTube channel and social media such as LinkedIn. I started getting noticed and, have been offered to speak on the subject. And as people have been asking me, what is data science and how do I become a data scientist? I've had to put a lot of thought into it. And yeah, I've got my own thoughts and opinions about what it is. So yeah, that's me. And we're looking forward to really getting into some, discussion about what we do as a data scientist. And where do you want to
Yeah, I
go
think
from
it's
here?
well, I think it's really interesting that you and I, Troy, have these kind of fairly deep backgrounds working with data.
Right.
Both of us were working with data long before we started calling ourselves data scientists,
That's
right?
right. That's right.
And it's been interesting to I made a more explicit transition into it, I guess, when it was already a thing that people called themselves around the place generally.
Right.
I think it's really interesting to hear about your journey and how, how you sort of found yourself in this field at the very outset. So
Yeah.
that's really neat.
So let me talk to that a little bit more because, yeah, as it turned out, this guy who came up to me at the conference was keynote speaker of the event, Saeed Shadbury, who worked at Johns Hopkins University, and his association with the National Science Foundation, the papers and things that have been coming out, talked about this data deluge, how we're going to get so much data, we're not sure what to do with and how to manage it. We need this new role. And yes, that was, I think, 2004, they wrote a paper. But even before that, people had matched those two words together. There was a little journal or something that talked about data science, but they never really put it as the data scientists. And it wasn't until this paper the National Science Foundation released saying we need this new role called the data scientist that then another company, JISC, what's their JISK, stands for it's just the United Kingdom not-for-profit company, provides network and IT services. I don't know what the JISK stands for. Oh, here it is, Joint Information System Committee. They did a report that was released earlier that year, 2008. And when I did my search about data science and data scientists, that popped up. And they really do talk about, this new role. They did the skills. We'll put a link to the article in the comments, but yeah, the role and skills of a data scientist. But that's where I built my kind of insight of what to do. And it's turned out that everything I read in that report, I was already doing. Like you said, I was already doing data management. I was coming from a computer science background. I was an information and kind of librarian technologist that, just wanted to sit next to these data, or that they have a phase of data curation, data integration, and data and now analytics, that the data scientists got to sit and oversaw everything as that interface to that world, whereas the domain expert understood about data, but their expertise was whether it's cancer research or environmental studies or
And I kind of ended up coming at it from the opposite direction.
right.
I was working at Hewlett Packard Labs in semiconductor fabrication of communications circuitry, and we had a need as R&D scientists and engineers to process massive amounts of data coming off of large silicon wafers with millions of devices on them that we were testing, right? And so that was sort of my introduction to the world of production coding. I was one of the better software guys on the team, so I put my hand up and I said, I'll build the ETL, I'll build the analysis. And so coming from that angle, not really having that much of a production software background, the challenge for me was getting to the point where I could achieve, 4 nines of uptime, like 99.99% uptime on my code, because when you're processing that much data, you can't really afford to fall over. It delays the whole operation. Right. Yeah. So we really came at this from different directions, didn't we, Troy?
Yeah. And that's what we hope to bring to this video and others to come, is kind of different perspectives. And we're looking for others to give their perspectives as well. So those that are watching, and please, if you have an idea of what is data science, and let's go back to that question, Dave. I know we were talking about it before, some little insights of how you would answer what is data science. And what I'm really more interested in is, what does a data scientist do? And kind of the distinctions we talked about, data engineering, data visualization, data management.
And look, those roles often are played by a single person in a startup, right?
Sure.
Like there's a lot of different roles in the data space, but one thing that I have seen from my experience in Silicon Valley is, I've worked with startups, I've worked with more mature organizations, and one thing that I've seen is that it's important, even when there's only 1 or 2 people in the data space in your organization at a very early stage, it's important to understand what roles those people are playing. Even if there's only one person wearing many hats, it's important to know what set of hats they actually wear.
Sure.
Because having managed technical teams and having seen technical teams grow, I've also seen that, like, if people are sort of confused about what belongs to what tasks belong to what role, like at first it doesn't matter, it's all in the one person's head, right? But as the organization grows and new team members are added and teams turn into bigger teams or and split off into like sub teams, you can end up with situations where you've got maybe a data engineering team and a data science team, But actually, the data science team is doing some core data engineering business and vice versa, because those roles weren't defined at the outset. And so even if you're just starting out, even if you're like an early stage startup, I think it's really important to have these understandings in mind so that you structure your organization. Because look, if you're starting a startup, you want to go into like scale up mode at some point. You got to be thinking toward that all the time, right?
Yes. Yes.
And so getting your head right at the beginning is actually pretty crucial to successful scale up without baking in these kind of structural problems that I've actually seen a number of times as a consultant and as an employee at companies at various stages. So to me, like kind of the core defining principle of data science is the science part. So to my mind, as somebody who's been a scientist for like pretty much my whole life now, which we don't want to talk about how long that is, do we? But it's been a while. The science part is about discovering things that you didn't know about before, right? I mean, and there's obviously a lot of overlap between data science and data engineering, data science and like straight software engineering, data science and like data visualization and interpretation. I mean, in order to do science, you have to be able to manage data and curate it and clean it and bring it in. And you've also and also from a business perspective, all the data science in the world doesn't really help unless you're able to get some kind of interpretation or visualization that people who aren't all stuck into the details can assimilate and use, right? And so I'm not arguing for like a rigid separation of responsibilities here, but I guess to me, the core of data science is that it's the sciencey bit.
Right.
Data engineering, the core of that is it's the engineering-y bit, right? Where you're focused on making a system work really reliably. And putting together well understood pieces, right, in an intelligent way, making those design trade-offs so that you have a good infrastructure, right? And I've definitely done plenty of that. I think all of us as data scientists have done a lot of data engineering and a lot of data visualization, right? And then on that other end, there's kind of the overlap between let's say, working out how to present your results in an intelligent way that's going to make sense to people, that's going to give them an interpretation. And then there's sort of the more like dashboarding end where the object of the game is to make it possible for business users to directly manipulate the data themselves so that they can access their insights in a more iterative way, I want to say.
Okay.
So there's kind of those gray areas, right? But to me, what really is the center of gravity, let's say, of data science is that science aspect, that you're finding out new things. And before there was data science, there was the thing called data mining, right? Where you were trying to mine out insights from data. Well, a lot of people say, it's just the next iteration of data mining. And then like data analysis, right? Well, I mean, that is a form of data science in my mind, because what you're trying to do is you're trying to pull out insights. Yeah, it may be like in an analysis context, you may be doing it kind of in a more manual, heuristic, ad hoc way, as opposed to the sort of more machine learning end of things where you're relying on an algorithm to pull out the insights for you. But those still all kind of make sense in that science context of discovering new knowledge based on the data that you have, which presumably which presumably is coming from a reliable source, that's the data engineering end, and going to a useful interpretation, which is more
Right.
like the visualization end.
Yeah.
So yeah, I think like that's kind of a functional description. It doesn't actually have anything to do with like what tech stack you're using or anything like that.
Sure. That's right.
It's sort of tech agnostic
Hmm.
in that sense. But I
Yeah.
think that's what makes it a useful definition, that people in all different industries and with all different tech stacks can have something in common, a common language, talk about
Right.
how
Exactly.
these roles work.
Yeah. And
So
I agree. I mean, to the point that I think is really important in terms of scalability for when you talk about data science and the data scientists, really taking in that aspect of the science or the discovery, or, finding something that we didn't know before. Um, the things that I see, I guess, not arguing the point, and you talked to them as about, but because I guess how I grew up, I'm a scientist in everything, even, the way I collect data, or even the way, I'm putting um, little IoT devices together, or the way that I'm just watching my computer run. So even though there's no new knowledge really coming out, or no discovery of something new, still I feel like there's still that science attribution to that I bring to everything I do, whether it's, and I talked about the layers, and let me mention those as well, where I see, this kind of physical layer where we have physical computers, and, data's are stored. Ultimately the zeros and ones need to be stored on some sort of media, and yeah, people who are in that space, I can consider, or I would consider, um, if they feel like they think they're a data scientist, they can be a data scientist without, because there's so much science that can go into it. And I'm using science as the broader term, um, rather than, a rigorous scientific method where you've got, a hypothesis and an outcome and a methodology. But yeah, I kind of like to lean against this kind of broader scope, that you can have science at the physical layer, where we're working out how much space we need, or is it going to overflow, or, how can we distribute the data across, the different, um, such as, decentralization and blockchain technology, or Hadoop infrastructure. So these sorts of things come into play, even though this is really at the physical level. And then in the middle, we kind of have this logical layer. And the logical layer, I believe, is the manipulation, the changing, the alteration or transfer of data, which can ultimately result in a software application, or it can ultimately result in, a machine learning algorithm, or it results in some sort of, aspect of uh, analytics. The data is analyzed. And then at the top layer, I see that, the visualization aspect, that kind of where you would see a UX designer, or, the human computer interaction really happening. And I think the beauty of it is that being a data scientist, you can come into that space from a number of different layers or perspectives. But I do agree, it's really important that, you have that ultimate science and that data scientist aspect. It's like baking a cake. So if the chef wants to bake a cake, that master chef is going to be the one that actually makes the cake. But, he or she may have a team of assistant cooks or chefs, and even right down to like the farmers that grow the ingredients could be part of that team. Now, like you were saying, if you're in a startup kind of mode or environment, having that master chef recommend that, they how can I join this to farming, like we were talking? So, okay, they need eggs, right? So if the farmer knows, sorry, if the master chef knows that this type of chicken, given this type of food, will lay an egg that will make his cake taste, really exceptional, then that chef is not the farmer, but it knows that and could actually have a farmhouse breeding the chickens and having them lay the eggs based on the food that needs giving them. So in that way, it's that's how I kind of see this kind of broader scope of the more the data scientist knows and understands about these layers, where the eggs are coming from, how it's stored, the less problems or more enhanced solutions that a data scientist can bring to the solutions. But yeah.
Sure. Yeah, and that kind of cross-functional optimization and communication is super important. I mean, that's the whole benefit of kind of interdisciplinarity and working cross-functionally in a team, right? And obviously, the more that we can reach across to our colleagues, if we're in a big team, or the more that we can sort of integrate our thinking across these different functions on our own, that's going to be really helpful. The flip side of that is that these sort of different functional roles actually often require different ways of thinking about problems, right? And so that's definitely been something that I've worked with a lot in my consulting business, for instance. So I've helped companies who really didn't have a lot of data experience or ability to use their data, like sort of activate their potential in terms of using data for like analytics or machine learning. And one thing that comes up over and over again, especially one thing that comes up over and over again is that data scientists and software engineers in some ways are trained with diametrically opposite ideas of what they're trying to do.
Sure.
So I mean, so part of the essence of being a good software engineer is that you know really well what your code is going to do in any possible circumstance. Right. That's a big part of the discipline, and that's why we have like unit testing and why people go through a lot of work to ensure that their code is like consistent between commits and looking at edge cases and all the other kind of the whole panoply of techniques that have been developed to make sure that we really understand what the code is doing, no matter what the world throws at it, right? Whereas on the other side, a lot of data science is about statistics, right? And statistics is, I mean, to my mind, a lot of what people do when they're doing data analysis, let's say, or when they're doing predictive modeling. It's about statistical reasoning, which is by definition uncertain, right? And so someone who's spent their life trying to become a better software engineer and nail down every edge case in every possible circumstance, like it's actually quite different to then encounter a mode of reasoning where what's important is, on average, are things working out? Or well, this edge case, I realize it's an edge case, and you might, in principle, you'd want to test for it, but how often does this edge case actually come up in terms of like the kind of data that you're dealing with? Right. And so that can and so that can actually be a bit of a tension even
Sure.
between the software engineering side and the data scientist side. The data scientist is often trying to iterate really fast in a very exploratory kind of way.
Hmm.
And then the instinct of the software engineer is, well, you're exploring, but you don't really know what you're doing, right?
Right.
You
Right.
know,
Yeah.
like, and so that's one place that's one example of where I feel like it's really good to try to have this to try to expand your horizons to understand other ways of thinking, so
Hmm.
you can understand your teammates or understand, just if you're on your own, the requirements of the different parts of your project. Because if you
Right.
start applying statistical reasoning to like your unit tests, and you're like, oh well, I don't, then a lot of the time it's easy from a data science perspective to come out with, well, I can't really write a unit test because I don't really, there are so many edge cases I'm not going to worry about.
Hmm. Hmm.
And that's why I personally am a proponent of what I like to think of as statistical unit testing, but
Right.
that's a conversation for another time perhaps.
Sure. But
Where you try to marry those two points of view.
sure.
Um, but I do feel like that's part of why it's important to realize what what function is actually being performed at any given time.
Hmm.
Because sometimes you have to be in a completely different mindset
Right.
for some aspects of the data space than in other aspects of the data space.
Yep. Yep. That's really true. I believe as well is that, I mean, I really aren't that big on unit testing. I am a Java developer. I position myself as an expert Java developer. There's nothing I couldn't develop uh, in Java. Yeah, as I believe, in that agile and iterative space, it's like I feel more of this. Well, I don't know whether it's scientific or, like you said, exploratory, is an exploratory mode of kind of seeing what works and what doesn't work. But yeah, I think for our audience and those that are exploring data science, and obviously if you're watching this video, you're interested in some capacity about data science. And um, so, yeah, um, what was my main point now is really about those that are interested in data science and how do you merge into data science. I think, yeah, science is the key. It come with it a different, mindset, as Dave, you were saying. There's different mindsets as being a librarian versus um, a machine learning expert or analytics. But knowing about each other's roles and what needs to be done on either side can really help things move effectively and efficiently. And yeah, if you're looking to merge out of your current role, whether it's in that space of data management or merging out of deep learning and machine artificial intelligence type of environment, then our advice, what I'm hearing from, if I can speak for both of us, is like think about these mindsets or different mindsets that you may want to take on, and yeah, take on this science kind of way of doing things, and I mean, I think that's interpretive itself, but yeah, in some ways we agree here. In some ways we have different opinions, but we're looking for your opinion. Those who's watching this, please let us know what you think. Is a data scientist and what a data scientist should do. What is data science as a whole? And if you're interested in attending one of our videos in the future, definitely reach out to us, and there'll be contact details or how to do that on datascientist.com. And but yeah, feel free to comment on this video, and as usual, as everybody says, give it a like, a thumbs up, and subscribe, and we'll know that, yeah, we're on the right path. Anything else from you, Dave? But we'll wrap it up pretty quickly.
Yeah. Yeah, I think this has been a really enjoyable conversation, Troy, and I'm excited to hear what people have to say back to us in
Yes.
terms of feedback about these ideas. I mean, it's certainly a conversation that people have a lot. What is data science? But the interest of it is I don't think it's resolved yet.
No,
actually, and there are many different angles on
yeah,
it.
yeah, we're going to keep the conversation going.
Yeah, absolutely.
Yeah.
Well, thank you,
Okay.
Troy.
Thanks, Dave. Till next time.
Till next time.